Okay, today I'm going to show you how to use a free graphing calculator called Desmos. So the first thing you're going to do is you're going to Google the word Desmos, D-E-S-M-O-S. And when you look it up on Google, it's usually the first one. It's 100% free. And we're going to click that, and then we go to Start Graphing. And over here, I want you to notice there's a bunch of different tutorials to help you do things. If you click on any of those, that will help you to continue this. All right, so you have 4 different tutorials that I'm going to eventually show you how to use. Regressions is what we're talking about right now, which are linear regressions. So in order to get a linear regression line or a line of best fit, the first thing we're going to need to do is add a table. And I'm going to just use the tutorial so you can see. I'm going to add, we'll add some sample data. And I'm going to add the plus sign, hit the table, and then I'm going to use just the data that they're showing me. 1, 2, 3, 4, 5, 6, the arrow over, that's 0 and 8/10. And then I've got 2 and 7/10. I've got 3 and 9/10. And I've got 4 and 6/10. And then I've got 5. Oops, I wasn't supposed to go up to 6. Remember, that will be an error. Now it says click here to add a new item. So after you do your table, then you hit the plus sign, and we're going to add another expression. If you forget, you can always go to the question mark and go back to the tutorial. Now type y1 equals mx1 plus b. So as I'm typing my y1, all I have to do is really, it says hint. To get y1, type y and the number 1. Or you can go down here. Here's your keyboard right down here. You can type it right there and just type, you can change it to alphabet, you can change it to numbers. Okay, y1. Then the next hint to get this about sign is on the keypad in the ABC section. So you have to click on ABC, and there you have your about sign. And then we have MX, I have to write 1. And then I have the plus sign and B. Do it on your calculator, you can do it on your phone. Now, I'm not going to use residuals, so I'm not going to add that. I'll show you afterwards. But right here, you have everything you need. So we've got my, if I were writing the equation, right, I've got the y is about equal to, my slope is 1.03, 1 3/100 x, and then I'm going to use plus 0.31. So my m is 1.03, my b is 0 and 31/100, and now we're going to go to the correlation coefficient, which is the r. So the r is equal to 0.96. Okay, that tells us whether it is a good line of best fit or a bad line of best fit, or does it have a strong relationship or a weak relationship. So when we look at correlation coefficients, let's move over, and I'm going to add another. When I look at correlation coefficients, okay, we're looking for the R, okay, and the R has a rating anywhere from -1 to +1, okay. We say that -1 is weak. No, I'm sorry, it's strong. And +1 is strong. Actually, they're both kind of perfect. It's It's a very strong relationship where 0 is weak. Okay? What the negative shows is actually the directionality of the line. So if you have negative, it would be a negative slope. If you have positive, it would be a positive slope. So when we have something like, if I go back to this, and we have that, I'm going to take it off writing mode, and we have that, you know, we would say that our equation is, let me go back here. So I've got my equation, I've got my slope, I'm just going to write it right here. We would say, if we're talking about the correlation coefficient, we're going to say that first you always have to identify and then interpret. Okay, so part 1, we're going to say, I'm not going to, we do this in complete sentences. The correlation coefficient is is 0.096. Since it's close to positive 1, that means it's a positive slope. And it is strong. So then we're going to say, what does this mean? This means it has a positive, strong correlation. And then the last sentence I'd like you to say is make a judgment about it. Does it mean it's a good line of best fit, or is it a weak line of best fit, or a poor line of best fit? So I would say this is a good line of best fit. Line of fit to describe the relationship between this equation was one that we worked on earlier. Oh, no, it wasn't. For whatever your two x and y axes are. Okay?